Okay, thank you everyone. My name is Gary Knights. I'm trying to step the light here. And the presentation is called Harnessing the Power of Network Data. And so what I'm going to talk about are the data structures that we built into the 2.0 network. Some of the issues with data structures, how we got to where we are, and what the data structures will deliver. See if I can get this recording tomorrow out of the way here. So, network data, the title of the slide is Network Data is the Next Frontier of Supply Chain Innovation. And so this is a report out of the Supply Chain Officer's report, and it just shows that in their survey of supply chain executives that big data was considered to be a big trend. We hear the word all the time. Second was digital supply chain. Another report was titled Making Big Data Work, Supply Chain Management by the Boston Consulting Group in January. And this quote says, the combination of large, fast-moving, and varied data streams of big data and advanced tools and techniques such as geoanalytics represent the next frontier of supply chain innovation. So these are just some thought-leading organizations that are providing some input around data structures and how it can be used and what needs to be in those data structures. So you might be asking, well, what is network data? So I define network data here as being the combination of all of the data that flows through a network. It could come from your ERP system, could be in your trading partner's ERP system, could be from network applications, like Elemica supply chain applications or global supply management, plus outside data feeds. The graphic shows on the upper axis, the vertical axis, the velocity and volume of data, and going from left to right along the bottom, it goes from structured data to less structured data. So in your ERP systems, data flowing through our network tends to be more structured data related to transactions. And so that really relates to the first three bullets that I have in terms of what network data is. And I think for the next few years, in terms of doing hardcore supply chain, analytics, predictives, I think for the most part you're really limited to those in terms of having automated routines. I think over time, as we can have social listeners add to it, we'll be able to find, okay, what are the right social listeners to bring in? But I think, my honest opinion is in the next 2, 3, 4 years, you're not going to have a whole lot of social listening coming in and making a real-time hardcore supply chain decision. That's just my opinion, but that's where our eyes are set. We do want to be able to take something out of a social listener, watch a Twitter feed, a non-structured Twitter feed, and be able to ultimately flow that into our network and do something with it to run a real-time predictive. Now, in the case of something like Conway, the gentleman who talked about social, Conway drivers are sending in Twitter feeds using social media to say, hey, I have an empty load. Now, something like that where it's actually semi-structured data, or we could come up with rules around it, that's a case where perhaps we could take social and start to do things with it to drive a real supply chain execution decision. But I think in the short term, it's going to be more on the realm of what's in your ERP system, what's out of your trading partner's ERP system. Those are the ones that are going to be driving the hardcore decisions. So it's kind of hidden here. Just pull this up out of the way. But in earlier 2015, we had a Elemica supply chain focus group discuss, okay, what are some of the top challenges that you see in the world around you. So I'll just let this build out. These are just some of the types of things that they notice. Raw material pricing, rail performance, wars, weather, first run quality statistics. What's the future? One of the things that people said they would love to have heard, this was about a year ago, was if someone could have told me in advance that there was going to be a snowstorm in Chicago, where the Chicago, United States, where the rail yards are, and that those rail yards are going to freeze. If I had known that, I could have possibly pre-positioned materials someplace or arranged for truck transportation. So that's out there a little bit, because we can't predict the weather all that well, and who's going to make big decisions, around weather prediction. But these are the kinds of things people are talking about. But if you look at this list of items that came up, I would say that network data can address around 70% of them. Now, there's a number of them that network data is not going to help us predict, what happened in Ukraine or what's happening in Syria. Network data won't help us with that, but it might help us figure out, okay, that a truck is going to be late. So, what we can do with network data is look at things like, will my carrier's performance, do I expect my carrier's performance in this lane, to be above or, below average, for example, because we'll have that data, and we could perhaps correlate that with similar situations. Or another one would be, batch, this is a visibility example. Batch XYZ, this could be a pharmaceutical, this could be food, has some sort of issue. So show me the list of all the serial numbers of that product that have been, that have that batch in them, and where are they located? And this is an example where network data really can shine, because we could have the data that came out of your ERP system, out of the carriers. Maybe that batch is on, your ship notices, and it has gone out, to 5 different locations. Now it's on, 5 or 6 different carriers. And so the information around the location of that is distributed. So that can be difficult for any one manufacturer to try to manually correlate. But when those transactions are going through a network, we would have that visibility. We would know what those serial numbers are. We know that that truck, has not yet arrived. Therefore, it's on the truck, and maybe that one can be turned around. And let you prioritize your efforts to, okay, these trucks with that serial number were unloaded. Go ahead and take specific action with that recipient. Maybe find out, okay, which ones have actually been sold, in the case of pharmaceutical food example, or which ones have been entered into manufacturing, and which ones have to pull them back. So as you look at information that is going across partners, that's really where network data starts to shine and gives you visibility over things you don't have inside your ERP system. So this really set the whole thing up of, okay, why is network data important? So the next question is, okay, how do we get this data? How do we get this data into the network? Because who here has heard of EFACT? Has anyone, so 3 people raised their hands now, in EFACT, let's say an EFACT 96A order, has anyone ever seen 2 companies use an EFACT 96A order in 2 different ways? Or does everyone in the world use that transaction identically?
Typically they're different.
Typically they're different. Yeah, people end up customizing the transactions. So even if you had all of your data coming in through one standard, one data standard, could you run analytics on it? No, I see head shaking back and forth. No, you couldn't. Okay. But there's not just one EFACT 96A standard. There's 96B, and there's X12. There's about 10 versions of X12. And there's SciX, and there's VBA, and different industries and different companies use different data standards. And if we can't get it consistent in one version, one data standard, guess what? Across all of the data standards, it's not the same. So basically, getting everybody onto the same data standard doesn't solve anything. Elemica tried to do that when we were formed in 2001. We actually thought that we could get everyone using the chemical industry data exchange. And we built our 1.0 network around the chemical industry data exchange, and we tried to get everyone to use that consistently. And what we learned over the years is that really doesn't work. The world won't conform to Elemica or even to the chemical industry. What we need to do is we need to make our network adaptive to the outside world. I like the quote at the bottom. The nice thing about standards is that there are so many of them to choose from. So now this is a mouthful. When we're talking about data standards with X12 and EFACT, I guess it's sort of poetic. The International Journal of Strategic Information Technology and Applications, I guess that's the magazine, There's an article published in it called Iterative Effort Reduction in B2B Schema Integrations via a Canonical Data Model. That, who knows what that means. And that was written by 3 PhDs from SAP in Q4 2013. And what it says is B2B integration still remains a big cost driver for companies. Yeah, with all the data standards out there, even an individual one being used inconsistently, integrating with thousands of trading partners is a hard thing to do. Not just at the connectivity level that Arun talked about, but at a data mapping level. And that's really where the rubber meets the road to have system-to-system communication. And so what they concluded was, instead of forcing companies to adapt to a single standard, what needed to occur was in the middle, you needed to have a network canonical. And they talk about that network canonical being evolving. Now, Elemica, we've been doing this for over a decade and a half, and we've known that for a long time, that we need to get off of SideX and get onto a new system. But it takes a long time to do that. It's like upgrading your SAP version. People here has upgraded their SAP. Is it something that you just install the disks? No. You have to re-engineer your company. And it's a bit the same thing with Elemica, because we have the chemical platform, we have the tire platform, we have to bring those two together, and we decided to use the merger as a way to build out a new, basically a new hub with new data standards. So when we looked at that, when we looked at our evolving canonical model, there were some people inside the company that said, well, look at how IDOCs are structured, or look at how FVAC is structured, or look at X12. And it's like, my view was like, that's not the right way to look at it. The right way to look at the problem is to look at, okay, let's model the real world supply chain and try to get the real world supply chain problems, like the physical problem. If we can't diagram and model the physical problem, we've kind of lost. If we went ahead and organized things around how X12 has done it historically or FVAC, we'd just be doing more of the same thing over and over again. So I think that the key thing that we did was looked at what does a complex supply chain look like? And so we looked at things like, packaged goods, boxes inside boxes on pallets. Then we looked at multi-mode transportation. You might have something put on a truck that goes to a rail yard. It has to be shipped overseas by plane. Then gets unloaded, or maybe it gets put on a ship and has to go by helicopter. Shipped to shore and then put on a truck and delivered. And then that one pallet might be for multiple customers and multiple destinations. So the pallet has to have a label on the outside that says, here's the route, and then when you unwrap it, there's labeling that says, okay, drop this stuff off at this place, and by the way, here's the accounting that goes along with it. So we tried to what if and go through some of the tougher supply chain problems that we've seen in our experience and could visualize. And we took a lot of input around serialization and track and trace to make sure that we had the right hooks built into the DNA of the new network data models, so that we could handle everything. Because I worked on integration projects in the past where the application programming interface wasn't well thought through. And you needed to have X number of data elements in it, but they simply weren't there. And then that was just kind of baked in, and you had to work around it. So we decided, let's make this as unconstrained as possible. And at the same time, another thing we looked at was life cycle maintenance of it. We know that we don't know everything now. So from the beginning, we took that as an assumption that things are going to change. There's going to be a new requirement that comes up in the future. So to the best of our ability, let's build out these data structures so that if we add something, we're not going to break something in the past. We can't guarantee that that's not going to happen, because something might come along that we really couldn't foresee. But to the best that we could, that's how we did it. Another thing is shared data model. So if you look at a lot of data standards, they were sort of built agilely over time. They did the purchase order in one set of meetings, and they came back to the certificate of analysis, and the definition and metadata around a product might be different in those two different messages. So that is going to make analytics hard, especially if trying to cross-company, cross-partner analytics. What's my shipment look like when it comes out of my system and is on a carrier system or is in a freight forwarder system? So we want to make sure that our data model across all the different transactions was consistent. So we take that in from the beginning. And Boston Consulting Group, just in June of this year, they came out with an article called "How to Avoid the Big Data Trap." And one of the big data traps is that data definitions aren't consistent. And there's a lot of hype about big data, Hadoop and HANA and memory processing. And at the end of the day, it really comes down to getting the data normalized. It's traditional business warehouse, analytics thinking that has to go into it. A lot of the big data buzzwords don't really address that. So we want to make sure our core data structures actually gave us a very strong foundation for it. So basically, as it says here, addressing that issue was a big priority for us. We put a lot of thought into designing our data model. So this shows the 6 main business process areas that we developed messaging for. Finance, that's your invoice, your payments, your freight invoice. Logistics, shipment status, ocean booking, shipment instructions, load tender response status. Order management, your order, create, change, response. Quality, your COA, test information. Serialization, requesting serial number from a manufacturer, if you're a toll manufacturer, getting serial numbers back, serial number hierarchies. Supply chain, getting into forecasting, demand, actual inventory levels. So these are the 6 main areas, and all use very consistent data model across them. If we add any, it's relatively easy, and we layer that into the existing data model. So this was a quote out of an article in Food Logistics that came out in August. And it says basically the farmer's ability to locate a precise position in the field allows for optimal application of seeds, fertilizer, herbicides. The amount of seed would depend on what their crop output would be. But then once you have the seed in the ground, how much fertilizer, how much herbicide. So if you have precision farming, to a certain degree, you can know if you have a certain seed, what was put on it. And you can start to develop a pedigree of that seed. Now, this is really an extreme level. It's probably going to be more around the whole field or something. But you can start to, as systems get better, you can start to identify, okay, this batch of crops had this much fertilizer, this much herbicide associated with it. And then as that food gets moved off the field, you can have essentially an e-pedigree of what is in that food, and that could even go into the, what then is manufactured into. So we're putting in place the hooks that, we can capture basically the e-pedigree of food, as it comes out of the ground, or even before it goes into the ground, down through the entire value chain. And so what this means in terms of ordering, another thing we put in was, so now that we can capture this batch information, lot information, serialization information, we can now support our canonicals. We're putting ourselves ahead of what your systems can do, basically. But we could support a customer that needs to, for example, place an order and specify the batch numbers and expiration dates. On our 1.0 system, we can't do that. But there's certain DLA scenarios where you might do that. You might actually need to specify a specific serial number, specific batch or expiration date. So, we thought through some of those things and built that into our data structures. Stronger support for packaged goods. This was a weakness in Cydex, and we pretty much modeled being able to have this lot of iterations. I think of it like we could shrink wrap 2 ships together and basically build up the palletized hierarchy of everything that goes onto it. That'd be a really big message. I don't think anyone can transmit it, but our data model can support that. Geospatial coordinates. So we threw in latitude, longitude, elevation, and even depth. If you needed to precisely locate something, that could be used in farming, or it could be used if you let's say you had a one-time ship-to location. It was going to be in a field someplace. You can specify that to latitude and longitude, but specify who the buying organization is and who the selling organization is. I don't think anyone's ready for that right now with their SAP systems, but if you needed it, we could handle that. And then across all of that, we did run a strong, consistent data model. To support analytics across everything. So some statistics. This is on the 2.0 data structures. Right now we have about 30 message canonicals, invoice, shipment instructions, order create. I listed out most of them already. About 56 major data structures that are shared across all of them. I think of these as being fairly highly engineered Lego blocks of information architecture that we're using to basically model the entire supply chain. We try to think about putting things into like type lists. If we need to add a new type of product ID, instead of building out a structure, have that as an attribute. So we try to think about that to make it easier to add new things to our data model without breaking what's there. And then we also thought through what are some of the unique data fields we're wanting uniquely named fields to make direct searches more efficient. So that's just a summary of what we built into our 2.0 data structures that are being rolled out right now. And then that looks like, I thought there was one more slide, but there's not. So that pretty much ends the slides, and we have about 5 more minutes before drinks start for questions.
When will it be available?
We are upgrading people right now onto it. So we have about 5 projects. To be honest, we're proving out some things as we map people onto it. But it's available now. We have people connected and transacting on the network.
We put a rollout for coming starting next year.
So sales is working with customers on upgrade projects to basically, take your system if you want to upgrade from the old system to the new system, to work with people on that upgrade. And so we're not doing that on our own in the background, but we're working with our customers on the upgrades.
I got it.
Yeah.
I got the message.
Jagger? Anything?
It's clear.
Clear? Okay.
To which extent will the old system and the new system coexist? You mentioned you're working with the upgrades with customers.
Yeah.
Maybe on the carrier side.
Yeah, so
I presume that priority is with the customers. That will fall at some point now, so we will initially continue to use the 1.0.
Yeah, so let me paraphrase the question. The question is, how long will the two systems coexist and how will that work?
Yeah.
So what we did was and you heard Rich ask Arun about this, we have a thing that is called the network bridge. So what we're doing is bridging across between the 1.0 system and the 2.0 system at a detailed subsystem level so that the two systems will talk to each other because we have multiple communication channels on 1.0. We have a connection with GXS. We have a connection with Axid in Europe. We have Clio software. We have Tumbleweed software that are connected into the network. We have specific connections around RNIF, for example, on 1.0. So what we're doing is we're bridging those 1.0 existing endpoints into the 2.0 system. Now, the net of all of that is that come November 30th, the two systems will be integrated so that we could receive a message that comes in on the 1.0 legacy system connectivity-wise and then route it over into the 2.0 engine for mapping. And so that's how a network upgrade would occur.
Using the network bridge.
Using the network bridge. Now all that does is it gets the data over to 2.0. There need to be a project to basically convert over the mapping and data structures in 1.0 into the 2.0 system to get the additional benefits of the new system. Any other questions?
Will the customers be informed, or was that a collaborative effort to move individual Elemica customers to the new platform?
That's another really good question. Will the customers be informed, or will it be a collaborative effort? It will definitely be a collaborative effort. Typically, we'll have, in the case of a supplier and their customers, and this is from the legacy chemical side, the supplier will initiate with Elemica to do the migration, and then we'll work with their customers, as they direct us to. If they say, hey, we want you to do the upgrade in the background and don't even bother to notify my customers, keep their connectivity the same, we won't notify their customers. But if they said, hey, as a part of this, we want Elemica to notify our customers, we would do that. And on the tire and rubber platform, which is the reverse of that, where the primary customers tended to be suppliers, we would do the same thing on the tire and rubber platform, the primary customers were procurement organizations. So in that case, if they said, upgrade my suppliers to the new network, we would communicate with their trading partners to the extent that they asked us to, related to it.
And how long do you think will those two platforms still coexist? Is there a certain deadline by when Elemica will have moved everybody to the new platform?
I mean, we would like to have everyone moved over as soon as possible, so that way we're not running two platforms and having the double cost of it. It's a good question, and I ought to have this date in the back of my head. We had previously announced, I believe, 2017 is when we wanted to have the cutovers done. I'm not sure, Robert, if you have a...
That is what I have in my mind.
Yeah. Are there any other questions? Okay, well, thank you all very much for attending. Appreciate it. And right out through the doors will be cocktails. So thank you, everybody.